everybody, welcome to another video. Hope you're ready to flex those brain muscles. In this video, we're going to talk about circles, parabolas, ellipses, and hyperbolas. In this video, as you can see, I have nothing written down, so the format's going to be a little different than the rest of my videos. I'm going to try something new, and I'm just going to work some examples. So normally I talk about definitions and kind of concepts, and then I work into examples. I give kind of a full explanation. In this video, I'm just going to do examples, and for a few reasons. The first reason is I'm a firm believer of the fact that in order to really get good at math and really learn math, you have to do math. So this gives everyone an opportunity to do math. So in the description below, I personally made a worksheet that has 8 problems on it. So there will be 3 links. There will be the worksheet itself, there will be the worksheet with my solutions worked out, and then there will be some notes on parabolas, ellipses, and hyperbolas. Just some notes that I wrote out. I figured I'd put them up there for people to use. So again, in order to learn math, you have to do math. So this is your chance. You can print that out, you can just pull it up, and I highly recommend to try to work through those 8 examples. Get as much as you can. If you can get through all 8, that's awesome. If you get stuck, skip to the next one, but get as much as you can done, and then play this video, and you can use this video to check your answer, to kind of summarize everything and get your ideas together. Yeah, I like this to kind of summarize general topics, and especially since my pre-cal class that I'm TAing for has an exam tomorrow, and like half the exam is over circles, parabolas, ellipses, and hyperbolas. So I think this is a good chance to test out kind of this video format. I don't plan on making a permanent change. Most of my videos will be the format that I'm used to, but if you personally like this idea and like this format, please let me know in the comments below. If you hate it, let me know as well. I want feedback from everybody. And again, this isn't kind of any kind of permanent change. This is me trying something that I'll probably just kind of throw in either before exams or just big general topics. I can just do derivatives and work a ton of derivatives and put the worksheet and the solutions and all that below, because I just want to give everybody a chance to actually do math instead of just watching me talk about definitions, concepts, and actually doing the examples. You get a chance to do the examples, which is really how we learn, is to put pen to paper and do math. So without further ado, let's go ahead and get into it. And again, if you don't have this pulled up, this might not make as much sense because I'm not going to write out every single problem word for word. I'm going off this worksheet that I have in the description below. So for number 1, find the equation of a circle with a center at 2, -3, and a radius of 2. So our center of our circle we're given, and that is 2, -3. And we're also given the radius. I'm going to write radius up here. We're given radius is 2, okay? So we just really need to remember our general formula for the equation of a circle, which is x minus h whole squared, all right? And the h is what? That is the x-coordinate of the center, right? Plus y minus k squared, and the k is the y-coordinate of the center. And this equals what? R squared, all right? And of course, R is the radius. So since I know my H, my K, and my R, I can literally just take those, plug it in, and I'm done. All I need is the equation. So this is pretty straightforward, but this is key to remember. Remember this general form for the equation of a circle, and you'll be good. So I have x minus h, and again, this is hk, right? 2, -3, that is hk. So for the x minus h, I have x minus 2 squared plus, and I have the y minus k. So this is y minus -3, right? I just want everyone to see before I write y plus 3 so I don't lose anybody. Y minus -3 is going to become y plus 3, right? Double negative there. So y plus 3, so be careful for that, squared equals r squared. My r is 2, so I have 2 squared. And again, I'll just go and replace that with 4, and that will be it. All it's asking for is the equation. For the next problem, we'll be graphing it, but for now, all it wants is the equation, so we are good to go. All right, so for number 2 here, we are asked to find the center and the radius and then graph the circle. So how do we start? Well, we use this tool that we learned all the way back in the beginning of algebra, and that's called completing the square. So we're going to complete the square, and technically we're going to do it twice because we got to do it with x's and y's. And yeah, we're going to do that, and because the goal is to get it into that form, that x minus h squared plus y minus k squared equals r squared. If we can get it into that form, the center and radius are really easy to find. We can just see it from that form, right? And then we can easily graph it using that center and radius. So let's go and start completing the square. The first thing I always do is move the constant to the right side. just because on the right side anyways, at the end, the constant's on the right side anyway, so I'm going to go ahead and move that to the right. And then the other thing I go ahead and do right off the bat, and again, I added 20 to both sides to get that to the right. The other thing I'm going to do off the bat is group the x's and y's together, because that's really what I need. I'm going to complete the square with the x's and with the y's. So I'm just going to kind of switch these two terms. It's addition, so the order doesn't matter. So I can just easily switch these two terms here, y squared plus 2y. All right, we're good to go. Now I can start completing the square process. So if you remember, I'm looking at these x and y terms, and I'm looking at their coefficients. So let's start with the x. I'm looking for the coefficient of the x term, which is 4. I'm going to take half of that coefficient, which is 2, and I'm going to square it. So technically it's b over 2 squared, and that's what I add to both sides. So again, half is 2, 2 squared is 4, so I add 4 to both sides. So I end up with x squared plus 4x plus 4. And then I can't forget to add that to the other side here. I'll put the plus 4 over here to remind me. Don't forget that. And then what do I have here? Y squared plus 2y. I do the same process. So in this case, my b, right? My b is 2. So b over 2, that gives me 1, right? And then I square 1, which is still 1. So I'm really just adding 1 to both sides. And again, I had to remember to add 1. So really what I added was 4 and 1. So I added a total of 5 to both sides, right? 4 and 1. So now these are set up perfectly. And the reason why this b over 2 squared works so well is because it gives me a trinomial that can be factored. Basically, it's a perfect square trinomial is what we call it. It can be factored into a binomial square. And pro tip, that b over 2, right? Half of this number, that always is what ends up inside the parentheses here. So remember, half of 4 was 2, so that's what ends up inside there. And then here we had half of 2 is 1, that's what ends up inside here. And then here we have 20 plus 4 plus 1, that gives me 25, which is nice because it's a perfect square, which makes getting my r easy, right? Because this is r squared is 25, so that means my r is 5, right? So again, now I have the center and I have the radius from this information. So all that's left is to graph it. So let's go ahead and write center at, and again, remember, this is x minus h is the equation of a circle. So I have x minus negative 2. So my center is at negative 2, and the same here, negative 1. And my radius is square root of 25, which is 5. All right, so now all that's left is to graph it. I'm going to sketch a graph. I need to make some room, though. I'm trying to see what I should erase. I don't know if this will be enough room. Maybe I'll erase up here. Hopefully everybody's good up to this point. Yeah, because I need to sketch my graph. All right, so let's see. I'm going to draw my y-axis and x-axis. Y, x. Hopefully everyone will be able to see this graph. Let's see, my center is at negative 2. That's 1, 2, 1. So that point there. And then remember, the distance from the center to any point on the circle is 5. That's what the radius means. So I'm going to pick, basically, I'm going to go left, up, right, and down 5 units, and then just draw a circle through all those points. So 1, 2, 3, 4, 5. I go all the way over here. And I'm not the best circle drawer, I'll be honest. On the solution sheet I have in the description, that example is a lot better. 1, 2, 3, 4, 5. But as long as you get the idea, 1, 2, 1, 2, 3. It's going to be somewhere way down here. As long as you get the idea. All right, and that's about as good as it's going to get for me. But again, this center is at negative 2, negative 1. The radius is 5, and we're good to go. We drew a sketch of this circle. All right, so for our next example, we have number 3. We're given some information. We're given a focus and a vertex of a parabola and asked to find the equation and sketch the graph. So if you notice, there is a pattern. For number 1, we were given information and asked to find an equation. For number 2, we were given an equation and asked to find some information, and that continues to alternate throughout the worksheet. I feel like if you know how to do both, for all four of these, for circle, parabola, ellipse, and hyperbola, then you should be good for the exam. If you can go from both information to equation and from equation to information, you should be good. So in this case, I can get everything I need to get the equation and graph this from this information. So the first thing I notice is that my x is staying the same. My x is 0. My y is the only thing that's changing. And that's important because I need to figure out which direction this parabola is opening. Remember, I have four possibilities: opening up, down, right, or left. All right, so four possibilities. So since our y is what's changing, right, the distance from my vertex to my focus is changing the y. So that eliminates left and right. We know it's going to be up or down. And since from my vertex to my focus, I'm going up 2 units, right, I'm increasing, we have upward it opens because the focus always goes toward the direction the parabola is opening. So we have upward, we have opening up, and we also have our A is 2 because that's what that A is, right? That A in our general formula is the distance from the vertex to the focus. So I've just found that A equals 2, and I found that we have a parabola that opens up, and that's important because we got to know which general equation to use, right? So how I remember these is I remember that it kind of goes along with the parent functions. So if I think of a parent function, I think of something like y equals x squared. That's a parent function for a parabola that opens up. So that's kind of similar to what this general form follows. We have x minus h squared equals 4a y minus k. And let me double check that and make sure that is legit. It indeed is. So again, we have something that looks very similar. Our x is squared, our y is not squared, and we have a positive coefficient, right? And think about that. So that's how I kind of remember. If you want to just memorize, I guess that works as well. But I just remember, oh, okay, we're opening up. That means my x is going to be squared and my coefficient is going to be positive, right? If my x is squared and my coefficient is negative, that's down. And you can continue that pattern of always going back to the parent function. So I don't know if that helps. Maybe it confuses you, or maybe it doesn't help, you haven't memorized, or you don't care. I apologize if that's the case, but again, our vertex is 0, 0. So this h and this k is 0. So we can go ahead and write minus 0, which is really just x, right? That means we have x squared equals 4. Oh, we know our a, that's 2. And y minus k, k is 0. So we have y here. So really, if we simplify this, it's just x squared equals 8y. All right, does it ask us to graph this as well? It does. So again, our vertex is at 0, 0. Vertex is at 0, 0. And we're opening up. So really, I don't have to be super accurate with this. I just have to know that my vertex is at 0, 0. I'm opening up. So I know that that point is 0, 0. And I just have to label my focus. 1, 2, that's the focus. At 0, 2. So I can write focus here, but really I'm good to go. That's a good sketch, and this is the equation along with the graph for the equation. All right, so now we are asked to find the vertex, focus, and directrix, then graph the parabola. Oh, I just realized we did not graph the directrix with the last example. We did not, but we'll do it with this example. But it would just be that A, but in the opposite direction, and it would be a line. Basically, it's perpendicular to the direction that the parabola opens. So in the last example, it would be y equals negative 2. It would be that line. But we'll see the directrix with this example. Sorry about that. Cool, so find the vertex, focus, directrix, then graph. So same process, I'm going to complete the square, but unlike with the circle example, I only have to do this once because I only have one term that's squared. So I can tell that since my y is squared, that I'm going to have, let's see, something that opens left or right, because that's the general form this is going to end up in. The x is going to be over here. I guess I can go ahead and move it to the right. I'll go ahead and do that. So y squared minus 2y equals, I add 8x to both sides, I have 8x minus 1. So again, with the equation for a parabola, only one of the variables is a squared term, either y or x. So since y is squared, we know we're going left or right, depending on if this coefficient ends up positive or negative, right? But first, I'm going to go ahead and complete the square here. So my b term is -2, so I take half of that, that's -1, and I square it, which is +1. And I add that to both sides. So I have y squared minus 2y plus 1 equals 8x minus 1 plus 1. That minus 1 and plus 1 cancel real nicely, so I can go ahead and erase those. So we are going to have a positive, so we're going to have what? It's going to open to the right, right? Because my coefficient for the x is positive and my y is the thing that's squared. But let me go ahead and finish this. I'm going to factor this. It is now a perfect square trinomial, so it can factor into a binomial squared. And now I have everything I need. So this is the equation. It definitely asked to find that. No, I guess it didn't. It said find the vertex, focus, and directrix. So we have the vertex here because my vertex is what? This is kind of like writing x minus 0, right? So my vertex is at, let's see, I know my x coordinate is 0. And my y coordinate is 1, right? Because I have that y minus k form. So my y coordinate is 1. What else? It has to find the focus. And this is where I really need that a. So a lot of people go even a step further and they rewrite this as 4, right, times 2x. Okay, because that 4 is always there, right? So basically whatever the coefficient is, if I divide it by 4, I get the a. So the a in this case is 2. Which means that the distance from my vertex to my focus is 2, and the distance from my vertex in the opposite direction to a point on my directrix is 2 as well. So since we've determined that we're opening to the right, we have our vertex here, and since a is 2, we're going to add 2, but we're going to add it to the x value, right? So going from my vertex to my focus, I leave the y alone and I add 2 to the x. So that's why it's really important to find out which way this is opening, depending on if the y is squared or the x is squared, because otherwise you'll get the wrong answer. You won't know what to do correctly. So directrix, and again, some people even prefer to go ahead and start graphing now and then kind of gather this information at last. So maybe I'll kind of do them simultaneously here. So I got my y-axis, my x-axis, vertex at x equals 0, y equals 1. My a is 2, and I'm moving to the right. So I have 1, 2. So that is my focus. And since I'm opening to the right, it looks something like this. Something like this. And what else? My directrix. So again, I go the opposite direction as the focus. And that distance going straight back the opposite direction, that is a point on my directrix. The line itself is actually, what did I say earlier? I said perpendicular to the direction that the parabola opens. I like that a lot because that's true. Since this opens to the right, my directrix will be up and down. So this is a vertical line. So a vertical line, so that means this is going to be x equals something. Remember, my directrix is always an equation, right? It's always a line. It's never a point or a set of points. So we have x equals -2. All right, so now we have vertex, focus, directrix, and we have graphed this parabola. So I think we're good to go to the next example. All right, so for number 5, we were given a center, focus, and vertex, and we are asked to find the equation of an ellipse with this center, focus, and vertex, and then sketch a graph of that equation. So unfortunately, with ellipse and hyperbola problems, there is a little bit of memorizing that comes into play because we have to find a, b, and c. We have to know what these values represent, and we have to find whether our major axis is vertical or horizontal, right? Basically parallel to the y-axis or the x-axis. And what this major axis is it's just a line, but it's the line that all of these values fall on, right? So our center, focus, and vertex are all along this major axis. So actually it's pretty simple to see what our major axis is in this case because all of our x's are 0. Only our y's are changing, which tells me that the major axis is vertical, right? It's a vertical line. And actually, since all my x's are 0, it's the line, let's see, x equals 0. That's a vertical line, x equals 0. So I've already found my major axis. So now I just need to remember what do A, B, and C represent and how do I find them, right? So A represents the distance from the center to the vertex. So I got what? From 0 to 5, that's 5. And that's each vertex, of course. We have 2 vertices. So the distance from the center to each vertex is 5. And then I have C, which is the distance from the center to the foci, to each focus. So that's 4, right? So those are pretty quick to find. Those are pretty easy. So the way I remember how to find B is I remember that this formula is kind of like Pythagorean theorem, but not. And that somehow helps me remember that it equals this, a squared minus b squared equals c squared. And on my sort of formula cheat sheet, I have this rearranged and solved for b because that's what you usually end up finding. But these two things are the same thing. This is just rearranged. I added b to both sides and subtracted c squared from both sides. So in this case, since we are finding b, it does benefit us to use this one. But if you're on your exam and you forget, just remember it's like Pythagorean theorem, but it's not. It has the minus, all right? I know it's a little bit confusing, but all right, so I'm going to go ahead and find b. So I have b squared equals 5 squared minus 4 squared, which equals what? 25 minus 16, which equals 9. So I have b squared equals 9, so that means that b equals 3. Hopefully everybody's following on that. So now I have my A, B, C, and I have my major axis is x equals 0. Now I have everything I need to graph this as well as to get the equation. So if you remember the general form of the equation, all right, so my x minus h squared, so in this case, actually my h is 0 and so is my k. So I'm just going to write x squared. I'm just going to write x squared because normally that h and k is the center, right? Those are the coordinates from the center, but in this case, they're both 0. So I have x squared over, all right? I'm going to leave that blank for now. Here I have plus y minus k, which is y minus 0 squared over, and this equals 1. So really the only tricky part is determining, is this a squared and this b squared, or is this b squared and this a squared? And the way I remember is that the a squared is always under the variable to which we are parallel. Our axis is parallel to, right? So since we are parallel to the, let's see, we're vertical, so we're parallel to the y-axis. So my a squared is going to be under the y. That's one way to remember it, but that is true with the formula if you just want to memorize it or whatever works. So again, our a squared is under the y, so under here we have 25. And that means this is our b squared, so this is 9 here, all right? And yeah, the x and y just stay in the same place. It's addition, so we can, the order of that doesn't matter. The only thing that changes is the a squared and the b squared. So now we can go ahead and graph. This is actually fairly simple to graph as well. This is my y-axis, my x-axis, and again, my major axis is the y-axis. The line x equals 0 is the y-axis, so this actually makes it easy for me. All right, I'm going to draw some tick marks here. 1, 2, 3, 4. 2, 3. And then I'm going to go up here. I'm going to go down. All right, so now what am I going to do? Let's see. I am going to start from my center. I have, remember, A is the distance from my center to my vertices. So I have 1, 2, 3, 4, 5 all the way up here, as well as 1, 2, 3, 4, 5 all the way down here. And then I have C is from my center to my foci. So I have 4 and 4. So those are my foci. So what is B? Do you remember what B is? Well, if I go from the center and I draw sort of perpendicular to the major axis. So since this is the major axis, perpendicular, that length of 3, 1, 2, 3, that's where my ellipse intersects, right? So I think of this sort of as the width of the ellipse. That may not be the, textbook way to think of this, but that's kind of how I think of it, is B is kind of like our width. So again, I'm connecting all these values here. So I'm going up to my vertex, I'm going down to the B value. All right, and that's perfect. We have here a focus. This is a focus, and this is at 0, 4. This is a focus at 0, -4. Both of our vertices are, let's see, that'll be 0, 5 and 0, -5. And then we have these points where they intersect. I guess you could call them the x-intercepts. I don't think it'll ask for that anytime in the exam, but okay, we found the equation as well as graphed it. So I think we've done all we needed to do here. All right, so now we are given the equation of an ellipse, and we're asked to find the foci, the vertices, as well as the center, and then graph it. So guess what we're going to do? We're going to complete the square. So I'm going to go ahead and get my x's together and my y's together. I'm going to bring the constant on this right side, and we're going to get ready to complete this square. So x squared plus 4x plus 4y squared minus 8y equals -4. That's how I'm going to set it up. And I'm going to start to complete the square process. So I got to do it again twice, to the x's and to the y's. So I take my b here, which is 4. I take half of that, I square it, and I add it to both sides. All right, so x squared plus 4x plus 4. And I can't forget to add 4 over here, so I'll just draw a little +4 to remind me over there. Plus, so here's one thing about completing the square, and it's in the video I made on completing the square. In order to do it correctly, your leading coefficient has to be 1. All right, so I have a 4 here, and that's messing me up. But luckily, I can factor a 4 out in front. And then what I'm left with is y squared minus 2y. And with this, I can complete the square. And basically what I'm doing is I'm completing the square within these parentheses. So I have to remember that this 4 is still being multiplied to everything inside here. So when I have this as my b, this -2, I take half of that and I square it and I add it. So I'm adding 1. All right, but what did I really add? +4, right? So really what I added is 4 to both sides. So I got to add another 4 out here. So I have this equals -4 plus 4 plus 4. A -4 cancels with a +4, so I just have a 4 left, all right? So I'm going to go ahead and finish completing the square. So this can be factored as a binomial squared. That's x plus 2 squared. This can be factored, and the 4 just chills out in front. But I have y minus 1 squared. And that equals 4. And again, for my equation, for my formula, I need a 1 here. So I'm going to divide everything by whatever is on this right side. And that's what you're going to do on all these examples. Divide everything by whatever is out here so I can get 1 here. So, right? So that's what I do. I divide both sides by 4. So I have 4, 4, and 4. So what am I left with? X plus 2 squared over 4. This is going to be my final equation. X plus 2 squared over 4 plus these 4's cancel. Now I have a 1 on bottom, right? This is y minus 1 squared over 1 equals 1. So my a squared, remember that's always the bigger one. My a squared is 4, right? Which means my a is 2. So let's see, where can I write this stuff? Hopefully y'all can see down here. My a is 2. My b squared is 1, which means my b is 1. And I can find my c because, again, a squared minus b squared equals c squared. So I have a squared minus b squared equals c squared. Hopefully y'all can see off here. So I have 2 squared, that's 4, minus 1 squared, that's 1, equals c squared. So I have c squared equals 4 minus 1, which is 3. So I have c equals square root of 3. I square rooted both sides. Hopefully I didn't move too fast. I don't want this video to be 2 hours. That's why I'm skipping a few steps here and there, but this technically should be review for my students at least. So I have my a, b, and c. What else do I need to find? Oh yeah, remember I said since my a is under the x, that means that I am parallel to the x-axis as far as my major axis. So let me organize this information a little better. All right, so I've arranged it a little neater. Here we already have our equation. We have a, b, and c. We have horizontal major axis. So let's double check what we need to find. We need to find the center, foci, and vertices, and then graph. So my center jumps out at me, right? We have that h and that k. So my center is, let's see, my h is at -2, my k is 1, so I have -2, 1. That is my center. And again, remember, since I have a horizontal major axis, my center is on the major axis. So now I know where my major axis is. So I'm going to draw my y-axis here. I'm going to draw my x-axis here. And since this point, -2, 1, so I go to 1, 2, 1. Here is my center, -2, 1. So that means that this line, let's see, it's y equals 1. is my major axis, that line y equals 1. So that's helpful to know because then I can use my A, right? Because my A is the distance from the center to the vertex. I can use that to find the vertices. I just go to the right 2 units. That's going to put me here at 0, 1. So if I write vertices, I have 0, 1. And I also have, let's see, I'm going left 2 units now. So 1, 2, I have -4, 1. -4, 1, right? I took this x and I added 2 and subtracted 2. So again, I do the same thing with my C to find the foci. So I could technically punch this in a calculator if I wanted to estimate, but I'm fine with root 3. I know it's somewhere between, root 3 is somewhere between 1 and 2. I think it's a little closer to 2. So I'm just going to kind of estimate and put about here. And as far as for my foci, I'm just going to write it in that term. I don't know. I just always feel like that's nicer. So again, I'm changing my x. I'm changing my x value. So I'm subtracting root 3. That's one of my foci. So I have -2 minus root 3, 1. And then for the other one, I'm adding root 3. -2 plus root 3, comma 1. And you could, again, punch this in a calculator if you want to see exactly where it is, but I'm good with this. So again, I have my major axis. I think this is everything it asked me to find. I just have to finish graphing. Since my B is 1, I know this line, remember, perpendicular to the major axis, so that distance is 1. And if I go up 1 unit as well, that distance is 1. And that's going to help me. Sorry, this is kind of small. I expected it to come out bigger, but it's just a sketch. Bam. Looks just like that. So that is my center, my vertices, my foci, as well as my rough sketch for this ellipse. So let's go and move on to the next problem. All right, so for this next example, we have find the equation of a hyperbola with center at 0, 0, focus at 3, 0, vertex at 1, 0. Then sketch a graph. So now we're moving on to hyperbolas for these last 2 problems. Similar to ellipses as far as we need to find A, B, C, as well as an axis. We don't call it the major axis anymore. For hyperbolas, we call it the transverse axis. But we still need to find whether this is vertical or horizontal. But the graph looks completely different. So if you aren't at least a little bit familiar with these, I would go and either look at another video or familiarize yourself a little bit. I'll make a more in-depth video in the future on this topic. But again, this is just to kind of help my class review and just kind of an overview of examples of these topics. But our A and C still mean the same thing. Our A is from the center to the vertex. So that distance is clearly 1. And from the center to the focus, I have 3. All right, so we have 1 and 3, and we may notice that our focus is further away than our vertex, which was the opposite for ellipses. That's something worth noticing. The B means something slightly different. It's not necessarily the width anymore. It is kind of the width, but it's going to be of this rectangle we're going to form, and I'll show you that in a minute. But we still need to find B. The cool thing is with hyperbolas is that, remember for ellipses, I said use Pythagorean theorem, but not. It has the minus, but in this case, we do use Pythagorean theorem with the plus. So it is consistent with at least something we already know. You know what I mean? So I'm going to solve for B. So if I get B squared by itself, I can use this formula here, and I can solve for B. So I have B squared equals 3 squared minus 1 squared. And that gives me 9 minus 1. That gives me B squared equals 9 minus 1, which equals 8. So that means that B equals square root of 8. If you want to simplify that, you can. That's 4 times 2. So I can rewrite that as 2 root 2. Basically, I rewrite that as 4 times 2, then I pull out the 4, right? So either way, though, I mean, or you could even punch this in a calculator and get an estimate if you'd rather do that. It all depends on you and what the instructions of the problem tell you. So yeah, now I have A, B, and C. What axis do I have? Well, again, all these points are along whatever my transverse axis is, very similar to the major axis. So since my y's are staying consistent, my x's are changing, right? So think of the x's changing. That means I'm moving this way. That means horizontal, right? Hopefully that's clear for everybody. Horizontal transverse axis. So what all are we asked to find? Let's see. Find the equation. Okay, so we can find our equation, and that's just from knowing A, B, and C and the direction of the transverse axis. We can find our equation. So I'm going to erase this scratch work. So with hyperbolas, we have a minus instead of a plus. With the ellipse, we had a plus. So that's really the main difference between when we're parallel to the x-axis versus when we're parallel to the y-axis, all right? So whichever is positive, whichever is the positive term, whatever that variable is, that's the axis that we are parallel to, all right? So in this case, since we are horizontal, we are parallel to the x-axis, which means that our x term is going to be positive. So that means that's the first thing out in front here is x minus 0. So I'm just going to write x squared, right? Because technically it's x minus h squared, but I have 0, 0 for the center. So I have here x squared over. And for the hyperbolas, it's a squared in both cases is the leading. The only thing that changes is whether we start with x or y, right? Depending on which one's positive, because this is always a minus. So here I have y squared. And again, on the bottom, it always goes in order here, a and b. I can flip these, but that would flip my transverse axis from horizontal to vertical, right? You can take a look at that sheet below. So I have a squared here, which is still 1. Here I have b squared, which was 8, if I remember correctly. So I guess technically I didn't really need to find, well, I do when I graph it. I kind of need that. It helps. And then what else do I need? So this always equals 1, just like the ellipse. This equals 1. So what else is it asking me to find? It said find the equation. We find the equation, then sketch a graph. Okay, so let's go ahead and use this equation to sketch a graph. This is my y-axis. Here's my x-axis. Center at 0, 0. Focus at 3, 0. So 1, 2, 3. And that means I have another focus at negative 3, 0, because again, just like with the ellipse, I have 2 foci and they're equal distance from my center. So my vertex is at 1, 0, and same thing, that means I have a vertex at negative 1, 0. So my vertex kind of determines I kind of have 2 parabolas opening up opposite ways. That's what the hyperbola looks like. So yeah, that's what my vertex is. These are just vertices of each sort of parabola. So what the B represents, again, remember I said it was kind of like had to do with a rectangle. So I do form a rectangle here, and the B is I'm still going perpendicular from the axis. So in this case, I have a horizontal axis, so I go perpendicular, just like with the ellipse. That's what we did with B. We went perpendicular and it met with a point. But this time it doesn't meet with a point. This time it meets with what forms sort of a rectangle that forms these asymptotes, all right? And this may not be required for what you're doing, but it is kind of cool. I don't know, I think it's kind of cool. So 2 root 2 is what? Square root of 8. That's somewhere between 2 and 3. So it's kind of somewhere up here. I'll just kind of mark it around 2.5. So then if I go down the opposite way as well, so this is kind of forming a rectangle. And why this rectangle is significant is because the corners of these rectangles, a line can be drawn through, and that line is an oblique or slant asymptote. They're called both. Oblique asymptote, I feel like it's more common. So again, if I draw a line, let's see if I can do this correctly, through here, so it's going to go through the center and through each corner, then that is an asymptote, as well as this line down here, all right, through both corners. So hyperbolas always have 2 asymptotes, and there is a formula to remember the asymptote. There's a formula, and I do have it on the sheet, but this is good to know, and the reason why is because you don't have to memorize a formula if you do it this way. You can do rise over run, right? And since my rise is my B value and my run is what? That's the A value. I have Y equals B over A. So in this case, that's 2 root 2 over 1 X. And the reason I have that is because my center is at 0, 0. Otherwise, it would be a little bit more complicated. But this is the equation, and oh, I almost forgot. This is plus or minus. Because the only thing that changes between these 2 lines is my rise over run flips to negative with this other line. So hopefully this makes sense. If you'd rather memorize the formula, then that works too. But this is helpful to graph because then I can easily basically tell where my asymptotes are. So I can do something like this because I know that it's headed toward those asymptotes. So let's see if I can do this correctly again. Headed toward those asymptotes. So I guess you could technically sketch it. If you're just asked to sketch it, you can do it without those asymptotes, but a lot of time in the question it'll say list the oblique asymptotes, and you'll have to list the equation for them. So again, these lines form the hyperbola. We have the center and we have the foci out here. And I think that's everything it asked us to do. Let's see, sketch a graph and find the equation. Perfect. All right, so now we're given an equation and we're asked to find all this information, right? We're asked to find the center, transverse axis, vertices, foci, and asymptotes, and then graph the hyperbola. So this is going to be a doozy, but let's go ahead and get started. So again, our negative x squared means that I'm going to keep this on the right because I always have positive minus negative. But I know that my y is going to be out in front, and that's going to be positive, and it's going to be minus the x stuff. So hopefully you can notice that right off the bat. But I'm still going to group my y's together, but I'm going to keep them up front here. So I have 2y squared plus 8y. I'm going to bring those out in the front, and then here I have minus x squared plus 2x. And I'm still going to bring the constant on the other side. I'm going to do what I've been doing to complete the square. So again, I can't have a number out here. This has to be 1, so I'm going to factor out the 2. All right, so I have y squared plus 4y. And that's going to let me complete the square within these parentheses. Half of 4, that's 2. 2 squared, that's 4. So I'm going to add 4 within here. But what have I really added? 2 times 4, right? So what I've really added is 8. So I got to make sure to add 8 over here. So I'll remind myself, I'll write plus 8 to remind myself to add 8. This is where it gets a little tricky. I want it to be this y stuff minus this x stuff. So what I'm really technically doing is factoring out a negative 1. This is how I like to do it. Factor out the negative 1. So I have minus x squared. But in here, what does this have to become? Minus 2x. So be real careful. That's a real common mistake, because that becomes minus 2x, all right? And now I can actually go ahead and complete the square. I have negative 2. If I take half of that and square it and add it to both sides, I'm adding 1 to both sides. But what am I really doing? Subtracting 1. So be real careful if you do it this way. Be real careful with the signs. I had to change this, and now I have to subtract 1 from both sides. So this equals, let's see, I still have that negative 3, right? That's still there. Negative 3 plus 8 minus 1, that's going to leave me with a positive 4, all right? Here I can factor both these. These are perfect square trinomials. I just completed the square, so I can factor this into y plus 2 squared minus x minus 1 squared equals 4. So I'm going to erase my 4 here. And now again, this needs to be 1, so I divide everything by 4. So I have divided by 4, divided by 4, divided by 4. So this becomes 2 over 4, that's 1/2. So really what I have here is y plus 2 squared over 2 minus x minus 1 squared over 4, that's still legit. X minus 1 squared over 4 equals 1. So this is the equation, all right? This is the equation, and I have it in the form I need it to be in, because now I can determine where my center is. I can find my A, B, and C, and I can find the transverse axis and all the stuff I need to find. So I'm going to make this a little bit cleaner. I'm going to rewrite it a little bit. All right, so I have my equation. I need to find A, B, and C. I need to find the transverse axis, and I need to find the oblique asymptotes. I also need to find the center, the vertices, and the foci. So I need to find those, and I can actually go ahead and find the center now. So let's see, center, and be real careful with this, because a lot of my students made this mistake where they just went, oh, negative 2, 1. But remember, the first coordinate always goes with the x. I have the x minus h is still here, even though this is in the second term. So I have 1, negative 2. That's my center. 1, negative 2. What else can I find? Well, again, that first term, that denominator is always a squared in the first positive term. So if my a squared is 2, that means my a is the square root of 2, all right? So I have a. What else can I find? Well, this is b squared. That means b squared equals 4, so that means b equals 2. So I found b. What else do I have? Well, that means I can find c using just Pythagorean theorem, remember? So root 2 squared plus 2 squared, that equals c squared. Well, root 2 squared is 2 plus 2 squared is 4. That equals 6. So c squared is equal to 6, which means that c is equal to the square root of 6. So I have some kind of ugly numbers here, and depending on what you do, you can keep them in the square root, or you can draw squiggly lines and put them in a calculator and estimate. Either way, it doesn't matter to me. It's up to, the instructions given. So let's look at this transverse axis, because remember, the transverse axis with hyperbolas, it's always parallel to whatever variable is in that first term. So in this case, we are parallel to the y-axis, right? Which means that we are vertical. So I'll just put a little parentheses here and write vertical, right? Because we know our transverse axis is going vertically. Oblique asymptotes, we can find those if we want, but I like to do that when we graph it. So I'm actually probably just going to go ahead and erase this and go to the graph. And we can use the graph to find the vertices and the foci. So I have my, let's see, y-axis here, x-axis here. So I'm going to go ahead and graph my center at 1, -2. All right, so that's my center. X equals 1, y equals -2. And since we have a vertical axis, this root 2 means that I can go up by a distance, by basically a distance or length, or however you want to think of it, of root 2, and that's going to meet with my vertex. And then I can go down by root 2, and that's going to meet with my other vertex. So my vertices, and since we're going up and down, we're only changing the y values, remember? So my vertices, both the x coordinates will be 1. But basically, I have -2 minus root 2. And then I also have 1, -2 plus root 2. And you can punch this in a calculator if you want and get an estimate. I think I did it and I had let's see, this is approximately, I don't know if you'll be able to see that on there. I'll have to write it really small. 1, and this is approximately -3.4. And this is 1 and approximately -0.6. So these are ugly numbers, but just to get an approximation, I prefer to leave them in this form. So that is the distance. So that means I'm right about here for that vertex, for that top vertex. And then at the bottom, I'm right about here for that bottom vertex. All right. So that means that my parabolas, this top one is opening up and this bottom one is opening down. My foci are going to be somewhere past that, remember, because they go past the vertices toward the direction that each sort of parabola is opening. And that's determined by C. So if I take, let's see, all right, foci here. If I take C, and I do the same thing, I add a C to this y-coordinate of this center. So my foci still have 1 for both the x-coordinates. And if I take C and I add it, so I'm basically adding and subtracting root 6, all right? And I get 1, -2 minus square root of 6. And I get 1, -2 plus square root of 6. And those can be estimated as well to this is about -4.5, and this is about 0.5. So going off of that, I have about 0.5 here. So I'm going about halfway. And then -4.5 is somewhere down here. So these are my foci. Maybe I should use a different color for the foci. Maybe I'll use red. So I have red down here. Oh man, that does not look like a pretty red. I think something's wrong with my red, but I tried anyway. Okay, so since I have that, I can actually start drawing, but I want to use my B, remember? Because that means I can draw a box, and I can go 1, 2, and I can draw a box from this vertex out here with a length of B, and then all the way down to this through this next vertex, and then out here with a length of B, so I'm going out to -1. And this box is going to help me determine, and if you'd rather use that formula to find the asymptotes, then go ahead and do that. But this box is going to help me determine where my asymptotes are, all right? So my asymptotes are here. So that means that it just makes it easy, in my opinion, to find the asymptotes. My rise over run, basically, right? I'm going from this point, from the center, I'm going up by A units. and then I'm going to the right by b units. So my slope of these lines is a over b, right? So my oblique asymptotes are y, and I have to use that center point. Y plus 2 equals a over b, so I have root 2 over 2 times x minus 1. So you can distribute this out if you want, and I almost forgot in the last example, this is plus or minus. You can distribute that out if you want, but yeah, this is the equation of the two lines that form the oblique asymptotes, right? So by being given that, I can go ahead and draw the parabola on the top, basically, and then on the bottom. So this is the graph of my hyperbola. Am I missing anything? Let me just double check, make sure I got it all. So I got the center, the vertices, the foci, the asymptotes, and I graphed the hyperbola. The transverse axis is vertical, and we could say that it's the line x equals 1 if they want the actual line, right? It is vertical, that line x equals 1. I think we got everything. This was a super long video. Anyone who made it to the end, that's pretty amazing. But yeah, this is everything. And if my students made it to the end, good luck on your exam. Just really go through some examples of this. It just takes time. Sit down with your notes, pick a quiet place, get a really big cup of coffee, and just do a bunch of examples and practice the best you can. And yeah, thanks for watching. If you have any feedback about this video, leave it below in the comments. I'm always open to criticism, to suggestions, to compliments, anything like that would be awesome. And yeah, check out all that stuff in the description. And until the next video, we'll get back to, my old format, but keep flexing those brain muscles. I'll see you in the next video.